Hi, welcome back. Today we're going to be starting a new unit. It's going to be Unit 4, Solving Linear Equations. So in this unit, what we're doing, we're no longer graphing, but we're going to be using algebra to be able to solve for a variable. A variable is a letter which is an unknown in an equation. An equation is anything in math with an equal sign. So that's why right now we're using this word equation, because we have stuff that has an equal sign and a variable that we need to solve for that variable. Solving for that variable means to make sure that the expression is the equation is true. So we have to find something right now that x represents that would make the left side equal to the right side. So in order to do that, we're going to be performing opposite operations, which is something that you learned last year in grade 9. Operations in math are multiplication, addition, division, subtraction. So we know that addition and subtraction are opposites, and multiplication and division are opposites. So what we're going to be looking at is our expression, and we're going to think to ourselves, what's happening on the left and on the right side? Can I collect any like terms? Is this a one-step or two-step equation that I'm solving for? And what operations can I undo? So if we look at our first equation, we have 5x equals 10. So we're going to put the letters on the left and the numbers on the right. Remember that trick that I taught you back at the beginning of the year when we were solving for equations for conversions between metric and imperial? So the same is going to ring true here. So pretend like that equal sign is almost like a wall. So we've looked and we've got our letters on the left, our numbers on the right, which means our variables and our constants. And right now on the left, I've got a 5x, but that 5 is almost attached to that x. And that attached x means that it's being multiplied. So we have to undo the 5 multiplying by the x, and the way that we do that is through division. So right now, if I did 5 divided by 5, a 5 can go into 5 one time. So that undoes that 5. So now I've got the x, which is all by itself. I don't actually need to write that 1, and I don't want you to write that 1. It looks kind of silly. But what you do on the left, you have to do on the right, and vice versa. So if you divided by 5 on the left, you also have to divide by 5 on the right. So 10 divided by 5 is 2. That's my solution. I now solved what x is equal to make the expression true. And we can actually perform a check with this. So the way that we would do that is that we would write down what our left and right side are and substitute the variable that we solved for. So on my left side, I have 5 multiplied by x. And on my right side, I'm given 10. So on my right side, I can't do any work. So the right side is 10. We have to make sure that this left side is also 10. We solved for x, saying that it's a 2. So we're going to replace that x with 2. And now we're going to multiply 5 times 2, which is 10. So now the left and right side are both equal. They're both 10. And we know that our solution is correct. So we'll continue practicing solving equations through the examples that are given. So for the first one, or second one here, we have p plus 5 is equal to 15. So we're going to think to ourselves again a little bit easier that we put the letters on the left, the numbers on the right, or the idea that we have to group maybe like terms together. So right now I can see that we've got a p, which is our letter, so that will be on the left. It doesn't move anywhere. But this positive 5 needs to move over to be with the number side, with the 15. This is one way of looking at it, but really what we're doing right now is before you were adding a 5 to a p. So the opposite of adding a 5 to a p would be subtracting a 5 from the p. And what we did on the left, we'll also do on the right. But this is tricky for students to see. So last year and this year, we've told you that instead of writing the negative 5 on both sides, simply imagine that you're taking the 5 and bringing it to the other side, which is changing the sign in front of the number. So we've written it in our class and last year as simply P equals 15 minus 5. And again, it doesn't matter the order that you write our numbers in or our letters on either side, as long as the sign in front is correct. So because the 15 didn't move, it stayed as a positive, while the 5 that did move changed its sign to a negative. So now we'll solve for our p-value. 15 minus 5 ends up being 10. So my solution for p is 10. I'm going to check this solution by performing a left side, right side check. So left side, right side. What is this left side and right side referring to? The left and right side of my equal sign. This is the left side of my equal sign. This is the right side of my equal sign. So on the left side, I've got a p plus 5. And on the right side, I've got a 15. So my right side's already done. So I'm going to go to my left side and replace p with what I think it is, which is a 10 plus 5. 10 plus 5 is 15. The left side and right side are equal to each other. Therefore, I did it correctly. So we'll keep going with some more examples. This next one here is a two-step. So the way that I showed you how to do this at the beginning of the year is to really put up this wall and then to put the numbers, the letters on one side and the numbers on the other to start with. I think this is an easier way of viewing how to perform opposite operations. So this 3D, we would group together and say that it's a letter. So it has to stay on the left side so it doesn't move. This positive 7 though is a number which has to move to the number side. So that means it's going to be a negative 7 on the other side of the equation because I'm moving it. The 10, which is a positive, is also a number, so it's going to stay on that right side. So now I'm left with 3D is equal to negative 7 plus 10. So negative 7 plus 10 is 3. Now I'm going to undo the second step by looking at what's happening to my D value. The D is being multiplied by 3, so to undo that, I'm going to divide by 3. What happens on the left has to happen on the right and vice versa. So 3 divided by 3, which is my solving side for my solution for the number, is 1. Again, we can check this because this was a little bit more complicated because it was a two-step solution. We can perform our check, which has a left side and right side. On my left side, I'll write in 3D plus 7. On my right side, 10. 3 times D, which is 1, plus 7. We'll use BEDMAS to solve, or we can just use our two-line calculators. 3 times 1 is 3. 3 plus 7 is 10. The left side and right side are both equal to 10. Our solution for D is correct. Let's continue on with some more examples. This one might look a little bit tricky, but again, view it as a left and a right side with numbers and letters, and then say to yourself, what operation is happening to that variable that I'm trying to solve for? So right now I've got a W that's being divided by 5. That's what that line means, right? It's a fraction. So say those words to yourself. W divided by 5. How do you undo that operation of dividing by 5? Of course, you multiply by 5. So when you multiply by 5, you would multiply by 5 on the left and multiply by 5 on the right. We know that every time that we're doing the opposite operation for adding, subtracting, multiplying, or dividing on the left side, the side where the variable is, it ultimately cancels out. Because what we're going to have is 5 over 5, which is 1. So we've got a W is equal to 5 times 5, which that's what this side, the right side, is being solved for. So W is equal to 5 times 5, which is 25. Now we might be saying, we should check this solution because it's new to us. It's a little bit more difficult. It looks like a fraction. And we can do that. So we'll check. On the left side, and on the right side. On the left side, I've got W divided by 5. On the right side, I just have a 5. My W is apparently 25. So 25 divided by 5, guess what? It's 5. They're correct. They're both equal to each other. Moving on, let's look at this side over here. All I'm trying to do is use example A again, but kind of switch up where that variable is. So I can find that my variable is on the right side this time, which is okay. Like I said, either way, if the letters are on the left or on the right, the idea is to get them separated from each other. So what's happening to this variable, this t? It's being multiplied by 4. How do we undo that multiplying by 4? You divide by 4. What you do on the left or on the right, you'd also do on the left. 4 divided by 4 is 1t, which that's what we were after. 16 divided by 4 is 4. Again, we want to check this. We can get actually a little bit quicker in checking this. Left side, right side. What we have on the left is 16, and what we have on the right is 4 multiplied by t, which is 4. 4 times 4 is 16. These sides are equal to each other. They're both 16. Let's keep moving along here. Negative 3c equals 9. Now here's what we have to be careful about. Thinking about addition, subtraction, multiplication, and division. When you're looking at this side over here, the left side, with that negative 3c, I'm saying negative. I'm not saying minus 3c. Because this number that's in front of the c is negative 3. The value is negative 3. The operation, what's occurring between the 3, the negative 3 and the c is multiplication. Okay, so you are multiplying still. But you're multiplying by not just a regular 3, a negative 3. So to undo that multiplying, we're going to divide. And we're not going to divide by just a regular 3. We're going to divide by the number that's in front, which is a negative 3. 9 divided by negative 3 ends up being negative 3. And then, of course, we want to check this to make sure that we're correct. So left side, right side. On the left side, you have negative 3 times c. On the right side, you have 9, positive 9. Negative 3 multiplied by c, which is also a negative 3, ends up being positive 9. A negative times a negative is a positive. So now both sides are equal, and we did it correct. Let's keep moving with some examples here. I'm getting a little bit trickier. Just to clarify, there's an x here, and in front of that x is a negative sign, which has a negative 1. So first, we're going to say to ourselves, what's happening to that negative 1x? It's being divided by 3. So before, how did we undo that division? Well, if I look up at d, w divided by 5, to undo w being divided by 5, we multiplied by 5. So to undo this x, or negative x, being divided by 3, I'm going to multiply by negative 3. Multiply by 3. And that'll cancel out my 3's. It doesn't change my variable. It doesn't make it a positive all of a sudden. So 5 times 3 is 15. Now what do I still have in front of this x? A negative 1. What's the operation between that negative 1 and that x? Multiplication. So to undo multiplication, you'll need to do division. So I'll divide by negative 1, and x will be equal to negative 15. Again, we should be checking this, so let's perform a check. Again, with our checks, we've got to be careful. There's a negative sign, so negative, which is actually, what did we say it was, a negative 1? Sure, we can write that in, a negative 1 multiplied by x being divided by 3. On the right side, you have a positive 5. So now let's fill in my negative 1 multiplied by negative 15 being divided by 3. We'll use BEDMAS. So negative 1 multiplied by negative 15, a negative multiplied by a negative is positive 15, which is then divided by 3. 15 divided by 3 is positive 5. They're both equal to each other. We did it correctly. We have to be careful with these signs. That's where a lot of us are going to lose our marks. So our next one that we're going to get to, which is again a two-step, we can look at as our left and our right side. We've got a t that's being divided by 12 minus 1 equals 1. Well, the first thing that I should do is get rid of any addition and subtraction because we're doing bedmass in reverse. So before we would do brackets, exponents, and then division and multiplication ahead of addition and subtraction. This time, because it's opposite operations, we're going to do addition and subtraction first before we multiply and divide. So that means the first step, I want to move this negative 1 or this minus 1 over to the right-hand side and turn it to a positive 1 or adding 1, because I want to get rid of that addition and subtraction first before I divide or multiply, which would be my second step. So when it's two-step, remember to always do addition and subtraction first, then multiplication and division. So now I'm going to add those the right side up, the 1 plus 1, which is 2. And then I can get rid of my division or multiplication. So what's happening to the t? Say it to yourselves. T is what? Being multiplied by 12 or divided by 12? Right now that t is being divided by 12. So in order to undo that dividing by 12, you multiply by 12. Now t is equal to 2 times 12, which is 24. So now we can check that, and this will be a good one to check because it involves two steps. So we've got our left side and our right side. We've got t over 12 minus 1, which should be equal to 1 apparently. So now we'll replace t with 24 divided by 12 minus 1. 24 divided by 12 is 2. 2 minus 1 is 1. The left side and right side are equal. We did it correctly. Now we're going to be looking at a very similar example. And maybe this one you can try on your own. So you can pause the video here. Okay, so if you've unpaused the video, this should be your solution. We're going to first move this negative 6 over, and it's going to become positive 6 as we did in our last example. That negative 1 didn't move, it stayed there. So we've got a positive 6, r divided by 3. Negative 1 plus 6 is 5, and we still have our r over 3. R over 3 means r divided by 3. The opposite of dividing by 3 is multiplying by 3. 5 times 3 is 15. That's my r value that we should have gotten. And again, we can choose to check this work. So on my left side, I'm going to say r over 3 minus 6. On my right side, I've got a negative 1. R we said is 15 over 3. 15 over 3. 3 goes into 15 5 times minus 6. 5 minus 6 is negative 1. So the left side and right side are equal at negative 1. And we've solved for our r value. Finally, last but not least, if you want to try this one on your own too, you can definitely pause the video here. Okay, if you've unpaused the video, that means that we're ready to solve. We've got 5w minus 5 equals 25. So we're going to save the 5w together because that's multiplication. So we'll save that to the end. First, we're going to get rid of that addition and subtraction. So we'll take that negative 5 and bring it over and it becomes positive. So 25 plus 5 is 30, and we still have this 5 times w. Instead of multiplying by 5, we'll divide by 5 because that'll undo our operation. 5 divided by 5 is 1. 30 divided by 5. So how many times does a 5 go into a 30? 6 times. And that's our final solution. And then, of course, we can check this. So the way that we're going to check this is that we're going to do our left and right side. We'll do 5w minus 5 and 25. 5 times 6 minus 5. 5 times 6 is 30. 30 minus 5 is 25. So we did it correct. Now on the next side here, we're going to be looking at our equation y equals mx plus b from our last unit and ultimately solving for different equations. So the expectation from the last unit is that we should be able to look at a graph and determine the equation of a line. This was really important, and I tested you on this on question 9 and 10 and received a lot of feedback from students about it, and that they had some issues and that they didn't know how to do it. So that's why this example is going to be really good to refresh how to make the equation of a line from a graph. So if we look at it, we've got Mark who's opened up a bank account, and apparently he put 150 bucks in this account. The graph shows his savings every single month. So Mark keeps going back and putting in money into the account. How much money does he put in every month? I don't know. We have to figure that out. That becomes our rate of change. Our initial value, or what he started the account at, is what he initially put into the account, which is our B, which is our y-intercept. So right now, by looking at this graph, we can easily identify our B value in y equals mx plus b. Our starting point of where this graph has the y-intercept is at $150. So we know that our B value is 150. But now we've got to come up with our M, which is our rate of change or our slope. We can see that our graph is going up and to the right, which means that it's a positive M value. And now I think the easiest thing to do is to create a triangle and count our rise over run to the next readable point. For me, my next readable point, you can have chosen any point. I'm going to just choose the first one since it's readable because it falls on the grid. So for my rise, to go from 150 all the way up to 350 means that I rose 150. And how about my run? My run, I went from 0 to 1. So my run is 1. So then I'll solve for my rise over run, which we had to do in our previous unit. My rise is 150, my run is 1. 150 divided by 1 is 150. So not only do I start at 150, but I deposit $150 every month. So the next month, after 2 months, I deposit another $150. The third month, I deposit another $150, and my account grows by $150 every month. So now it's asking me, write the equation in the form y equals mx plus b. So we'll write out y is equal to, our m is 150. Don't forget your variable x. X is the x-axis, which is the number of months. And y is the y-axis, which is your savings. Plus my b, which was my starting point. I started with $150 in the account. Now with this equation, we can solve for the x and the y value depending on what it's asking for. So before we solve for that x and y, let's have a better understanding of what the equation means. The m represents my slope, which in this example means that every month, or my slope is the amount of money that I deposit into the account every month. So the amount Mark deposits monthly. The B value is my y-intercept, which represents the initial value, which is the amount of money Mark starts the account with. So now with that understanding of slope, we should also maybe clarify what this y and this x represent. So like I said before, the y represents the savings because it's the y-axis, and the x represents the time. Now in the next question, it's going to ask me, how much will Mark have after 10 months? It's providing me with the time, 10 months. How much is how much money, how much will I have in savings after that period of time? So if I write out my equation, y equals mx plus b, I'm going to be replacing all of the variables that I know for this equation, which is 150x plus 150. But I also know something else. I know 10 months. Months is time, and time is the x value. So now I'm going to replace my x with the time that's given to me of 10 months, and I'm going to use my calculator to solve. 150 times 10 plus 150 is 1650. And then you can write a therefore statement saying that after 10 months of saving, Mark will have $1,650 in his account. The next question is going to look a little bit different. If Mark wants to save $3,000 for college, how many months will he have to save in order to have that $3,000? So again, we're going to start with our equation of 150x plus 150, and we're going to think to ourselves, what does that 3,000 represent? Is it time or money, which is savings? It's savings. And savings, which is money, is the y value that we're replacing. So in my equation, y is going to be replaced with $3,000. And I'll complete the rest of the equation by solving for x, for how long I have to wait to save that $3,000. So then this becomes like the equations that we were doing on the first page. So if I look, I've got 3,000 equals 150x plus 150. I'm going to first get rid of any addition and subtraction, so this plus 150. I'm going to move over to be with this 3,000, which then becomes minus 150 because it's moving over to the opposite side. So 3,000 minus 150 is 2,850. Then I have 150 multiplied by x. To undo that multiplying, I'll divide, because we're putting in 150 bucks every single month. So x, which is my time, ends up being 19. 2,850 divided by 150 is 19. So you would need to save for 19 months in order to have $3,000 in your account. So this concludes the first lesson, and now you'll be given homework to complete.